So we've got some charge here, Q, and it's got an electric field coming out of it. And we've been told that 2 centimeters from the charge, so this is 2 centimeters. Then there's a point which is at 12 volts. So all along this ring here will be at 12 volts. And we're asked to use this to find out what this charge is. So we know that charge is related to the voltage, so V is equal to KQ on R. So we can rearrange this to make Q the subject. So Q is equal to VR on K. And then these are just numbers that we can substitute in. So the potential difference, the voltage is 12. The radius is 2 centimeters. So that's 2.0 times 10 to the minus 2. We could put it as 0.02 if we wanted. And then divide by K, which is 9 times 10 to the 9. 9.0 times 10 to the 9, two significant figures. So solving this on the calculator, we get 2.7 times 10 to the minus 11 coulombs is the charge at Q here. Now the next part says what would be the voltage 4 centimeters from charge Q. So now we're considering this point here, well this ring here, which is 4 centimeters from that charge. So in order to do that, we can look at this equation here, and we can see that if we replaced R with 2R, because 4 centimeters is double 2 centimeters, then we're going to end up with half the voltage. So if we double R, we halve V. So this tells us that the answer is going to be 6 volts. Now, that's the fast way to do it. If you want to do it the more mechanical, slow way, of course, you can just substitute into this equation now that we know Q and calculate the new voltage. Then in the third part, we're asked, well, what is the voltage 1 centimeter from this charge here? So here's 1 centimeter. So in this case, we've halved the radius. So if we halve the radius, then we're dividing here instead of by R, by half R, which hopefully you can see that means that we'll end up with double this. So if we halve the radius, we double V. So that will be equal to 24 volts. So that's the answer to the third part. Now, it also asks us to think about what the equipotential surfaces, how they would be spaced. And so if we were to sketch a little diagram, here's plus Q, and we wanted to draw surfaces which were all, say, 5 volts apart from each other, it's going to have a 1 on R relationship. So initially, they'll be quite close to each other, like this, but then that distance is going to increase as 1 on R. So they'll get further and further away as we get to the smaller voltages. So the equipotential surfaces would look something like that. Sorry about my really wonky circles.